Welcome to our session on looking beyond and coming together using NASA and AgMIP tools for food and agriculture. The sessions are in two parts. First, we have the panel here on the main stage. And then we have a breakout session, which will give us an opportunity to continue our discussion about this really important and challenging topic of really bringing the latest advances in NASA technology and AgMIP and the models that we use, but really just in discussion to really learn how they can be the most useful for agriculture and food. NASA missions and models and AgMIP tools have an important role to play in advancing sustainable food and a healthy planet, and in responding to humanitarian crises, including famine. At the farm scale, remote sensing can be used for seasonal climate prediction and yield forecasting. At the global scale, NASA satellites track water availability for crops through soil moisture sensors. NASA global climate models play an important role in projecting the impacts of climate change on agriculture. And AgMIP utilizes these products and tools to help countries develop resilience for their farming regions. The session has several guiding questions. The first is, how can NASA and AgMIP tools advance sustainable systems and planetary health? How can we bridge the scales between global assessments and regional food systems on the ground, and between the short term, like seasonal forecasts, and the long term, the challenges of climate change? And finally, the third question is, what is AgMIP learning about climate change resilience and decision-making in Africa and other developing country regions? So our plan for this panel is we have our keynote by Karen St. Germain, and then our two other speakers, Alex Ruane and Laura Tal. Then I'm going to ask them each one question, and they're thinking about their answers. I already asked them as we were waiting. They're thinking about their answer to the question, really, of how do we go forward and what's most exciting as we go forward. But then we want to do all this so that we get to have discussion with the audience, Q&A with you. So please also, you be thinking of your questions as well. So I'm now turning to the introductions of our three speakers. Our keynote speaker is Karen St. Germain. She is the Division Director of the Earth Science Division in the Science Mission Directorate at the National Aeronautics and Space Administration, AKA NASA. I think everybody knows NASA around the whole world. She provides executive leadership, strategic direction, and overall management for the entire agency's Earth science portfolio. It's focusing on our own home planet, from technology development, applied science, research, mission implementation, and operation. Our second speaker is Alex Ruane. Alex is a research physical scientist at the NASA Goddard Institute for Space Studies and an adjunct research scientist at the Columbia University Center for Climate Systems Research in New York City. We're the co-leaders of the group of climate impacts there. Alex serves as the science coordinator and the climate team leader for AgMIP. You're going to be learning about AgMIP in this session. His research uses climate and impacts models to examine the influence of climate variability and change on sectors including agriculture, water resources, urban areas, infrastructure, and many more. This is leading to the development of adaptation strategies and decision support tools so that stakeholders can effectively manage climate risks. Our third panel member, recently arrived from Africa, is Dr. Laura Tal. Laura is an agroecologist and research director of IPAR, which stands for, I'm going to speak a little French, Initiative Prospective Agricole et Rurale, IPAR. It's a West African think tank based in Senegal. Laure is the leader of the AgMIP A team, that stands for adaptation, in Senegal, helping decision makers develop the country's national adaptation plan for climate change. And with that, Karen,
all right,
please look forward to your keynote.
Thanks.
Thank you.
All right, it is such an honor and a thrill to be here with you this week to celebrate Cynthia's accomplishments, the award, but also all the work that has led up to that recognition. And you would be, if you were asking yourself about why NASA is in the house, that would put you in the same company with all the folks who asked the same question at the Commodity Classic this year. So let me try to tell you a little story about that. So let's see, do I have the clicker here? I do. All right, so thank you for the kind introduction. I'm Karen St. Germain. I run the Earth Science program for NASA. And most people, when they think of NASA, they probably think of going to Mars, going to the moon, maybe the DART impact, if you happen to catch that video a few weeks ago, or the Webb telescope. What folks don't really know is that the planet that NASA studies the most is our home planet. Earth science accounts for about 10% of NASA's budget. That means we're putting a little more than $2 billion a year into the science behind understanding how our Earth works. This is just a depiction of the 25 missions we have, satellites with instruments on board, looking down at the Earth, observing all aspects of the Earth system, from ocean circulation to biomass, to precipitation, water vapor, soil moisture, all of those physical attributes of the Earth system. And those observations today, you may not know it, but you're already using them. Satellites like Landsat, like the Global Precipitation Mission, or SMAP, the Soil Moisture Mission, the data from those missions make their way into products that are used every day by the agriculture community, monitoring drought, monitoring soil moisture and precipitation that feeds various USDA information products. We also, because NASA uses that vantage point of space to observe the whole world, we aren't only focused on the United States. We can see what's happening around the world, and what you're looking at here is a crop map, again, generated by the AgMIP team, looking at crop production in Ukraine, and in particular, in this analysis, studying the relationship between the front lines in the conflict, in the war there, and the relationship to agriculture production, to what crops, what's happening with the crops. Are they being planted? Are they being harvested? Are the fields lying fallow? Or have they been set on fire? So these kinds of analysis can actually help us understand the impact of global conflict on global food security. And by the way, I should have mentioned that last image brings together data from NASA satellites, data from European satellites, and data from commercial satellites, high-resolution imagery from commercial satellites, to get that clear picture. So from this unique vantage point of space, we can see how the Earth system is changing. Increasing temperatures are increasing they're amplifying the water cycle. That is to say, we're seeing storms become more intense, and in many cases, more rapid intensification. We're seeing flooding on the coastlines, but also inland. And then in other areas, in drier areas, we're seeing more extended and severe drought. So these are the kinds of information we can provide today. Observations, though, give us understanding. And when we have understanding, we can capture that in models. And when we have models, we can start to look toward the future. And that's really, I think, where the power of what we do can be unleashed. So how do we prepare for a future knowing that the conditions around the world are changing and will impact global food security? Well, this is where the integration of what we at NASA do with what the agriculture community does can become really powerful. Integrating our data and our models with crop models can get us tools that help us look into the future. So this is an example that's from the state of Iowa. You're looking at soy and corn yields over a couple of decades here. And this comes from that integration of Earth observations into crop models. So these are calculated yield numbers. The brighter the color, the higher the yield. And then we do some validation to we validate that the output of these models actually is consistent with what we saw in those years. So in this way, once we develop a validated model, and this was based on observations that we made at the time, as well as information about genotype and management practices at the county level, we bring those together through these models to make these analyses. And once we have that kind of tool, then we can start getting the attention of governments like Kenya and working through our SERVIR program, which is a partnership between NASA and USAID, to help to support countries around the world, I should say, in better managing their risks. So this was a particular project where there was a real problem with insurance in Kenya. There were many, many uninsured farmers, and the government wasn't in a position to address that problem. But with the kind of information coming from NASA satellites and models, the government was able to put this program in place that reduced the cost of their data collection. They no longer had to go out into the fields to collect data. They could use satellite data to solve the problem. That helped them dramatically increase the number of insured individuals. I'm trying to draw an arc here from using data to understand what we're seeing right now to looking a little bit into the future, and now in this last animation, we'll look even further into the future. And I want to be really clear. What I'm going to show you here, again, it's AgMIP work. It's not a prediction, but it is a projection in which what we do is we project the climate conditions, in other words, the temperatures, the rainfall, the kinds of conditions crops will be facing, with the aspects of the model that humans control, the what we plant and the how we manage it. Now in this projection, we're holding constant what we plant, where, and how we manage it. And we're running into the future environment that we're going to see. And this starts to show you where you might expect to see pressure on, in this case, corn yields and wheat yields in the future. And let me just run that one more time, see if I can do that. There we go. Because one of the things that you can see is that you start to see pressure, particularly on corn yields, in the very near future, within about a decade. This tells us where we might want to spend some resources thinking about how to adapt and mitigate. So the idea here, again, is not that it's a prediction, but it's the kind of tool that we can develop, co-develop, and use to help inform future decision-making. So that's how I wanted to frame this. You'll hear more from Alex in just a minute, and I hope we have a good conversation about how we can better work with the agriculture community, put more tools in your hands, share the science that we have to help you secure our global food sources. Thanks. Great.
All right. So thanks, Karen. It's really my pleasure to be here, especially to be co-celebrating with everything that Cynthia has done. We're very proud in the AgMIP community for all that's happened. Let me see if this is working. Oh, looks like it advanced several. Hold on. All right, so I'm Alex Ruane, and I am here presenting results on behalf of the worldwide AgMIP community. I'm going to tell you a little bit more about what that is. There are several people in the room and all around the world that have been working on these big challenges. So I'm going to focus on AgMIP community activities to address global food challenges. And what do I mean by that? We know that in the agricultural sector, there are a lot of demands. There are many people asking for many things. In particular, the world is asking the agricultural sector to sustainably increase production, to provide healthy food for growing and developing populations, while at the same time adapting to climate change and ongoing climate extremes, while simultaneously mitigating emissions from agricultural lands. And of course, none of this will happen if there isn't a financial incentive for agriculture. So every one of these challenges is substantial, but when you put them all on the table at the same time, we see these interactions and the size of the challenge ahead of us. So one of the things that motivated AgMIP, which is the Agricultural Model Intercomparison and Improvement Project, was the idea of what will it take to start to attack and to grasp and grapple with these problems. So it starts with a fundamental set of connections, which up until AgMIP's launch had been, unfortunately, too siloed. The fundamental connection is between crop and livestock models and agricultural economic models. Having a way of communicating both on a data, but even in just a language sense between these communities was something that had been lacking. And then this diagram is also meant to indicate stacked models, because the idea also was, how do we get the different modeling groups to talk to each other and intercompare their sets of results? So the AgMIP project was launched and created in 2010 to provide a community for systematic improvement and application of multidisciplinary, multi-model, and multi-scale frameworks for agricultural development and food security. And the way we did this was by connecting these models and even thinking bigger about just how do agricultural models represent the physical, biophysical, and socioeconomic spaces. To understand the current situations, we had to start with observations. This is where NASA comes in. This is where our partnerships with leading agricultural institutions around the world are so important. But if we understand the historical climate and the policies in which agriculture is undertaken, we can run through these models so we evaluate and intercompare how well they do, and we can further calibrate and improve the modeling systems that we have. Once we iterate through this process, we gain trust in the models, and then we can go to the future standpoint, where we now have changed environments, future climate, different policies, different incentives. And when we run those through, now we can talk about the future of agricultural production, trade, food security, and the adaptation, mitigation, and other extended applications that we can use these models to explore. So behind AgMIP is the fundamental drive to produce this next generation set of knowledge, data, and tools to apply these models to understand sustainable farming systems and the options and costs and benefits related to those, and to perform coordinated assessment at both global and regional scales so that we can understand the implications of the various challenges and the various decisions being made in the agricultural sector and among others that are influencing the agricultural sector. So the fundamental process, of course, is based on models responding to key environmental changes. These include things like cyclones and extreme storms, but even more fundamentally, extremes of heat, from frost to heat waves, extremes in the water cycle, from drought to flood, additional challenges like air pollution and ozone, as well as pest and disease pressures. And this orange plus in the middle is carrying a lot of weight, because this is just a small sample of what we now know are a tremendous list of conditions that put pressure on agricultural systems. But if we can understand these fundamental responses, we can monitor, including from space, how well we're doing. And we can get up to this line that I've drawn in the middle at the bottom of this timeline. That's today. From there, we can go forward and think about forecasting, but we can also go backward and think about what has happened in the past. We can understand what was the cause of that yield shortfall in the past, And could we have done some other type of management to potentially have a better outcome in the past? So these ideas of what if we had planted earlier? What if we had used a drought-resistant variety? Could we have done better? This helps us understand the process. And of course, if we go in the other direction, if we keep going forward more and more lead time into the future, we eventually get to the point where we can't really forecast or predict the specific future. We can project what will come as conditioned on the various choices we make around climate change, market shifts, changes in policies, socioeconomics, and the overall larger questions of environmental sustainability. This is very important because it allows us not to just be reactive, but to be proactive in the types of preparations and the types of partnerships that we make to deal with the longer term challenges. So within AgMIP, this fundamental connection of models, the fundamental idea of iterating and improving and systematically addressing these challenges has led to a community of now more than 1,200 experts around the world, and more than 50 protocol-based activities where we work together to intercompare and improve our models as well as apply them. I'm going to go through this very quickly, but one of the fundamental things we do is we build process improvements using field experiments right at the ground and even lower levels. This has led not only to improvements in evapotranspiration, but we even organize some of these things around specific crop species intercomparisons. And just to give you an idea what we're talking about here, this is a simple representation of a field, but looking at several different ways that we examine the field and several different things that we're looking at. So of course we want to be able to look down from space and understand what we can see from there. We also have drones and other remote sensing approaches that we're factoring in. We look at the weather, we look at irrigation and water resources, greenhouse gas exchanges, pests, diseases, weeds, the fundamental growth of the plant and its root system and soil environment, and of course also the people and the equipment and other things that we bring into the field and the way we manage it. Just as an example, our wheat model intercomparison now has more than 40 different wheat models using the same data so we can understand how well we're doing on this. And we're trying to add more and more of these components as we go. Another thing we do is the global crop model applications, taking what we learn on a species level, then applying it to the whole world. We just saw this animation from Karen, so I'll just highlight one of the future years here and note that these are the types of models we're using to look out into the future in this high emissions scenario. That was 12 different crop models with 5 different global projections that we use to go out into the future. And we're validating those models in the current period and understanding them on several different levels. We're also looking at combining our global perspective with regional perspective and going across different disciplines. So an idea of what this looks like is maybe best addressed with a quick story, which is that what happens in the upper left in a specific farming system is just one example of many farming systems around the world in that upper right quadrant. The total global production drives many global markets and prices and imports and exports, and that in turn influences what happens in regional markets, feeding right back to the decisions made on the farm that year and the next year. This is an interacting set of exchanges that requires biophysical models as well as economic models. It requires regional as well as global perspectives. And we're building models in all of these quadrants and trying to get them to talk to each other so that we can consider climate, development, policy, and various nutrition and dietary scenarios. One of the other things we do is we work to think about the future, not just in terms of climate change, but understanding that there will be no future climate change affecting the current agriculture. It will be affecting some future agricultural system. So we have to simultaneously think about trends and development pathways in the agricultural sector. And one of the ways we do that is through sustained stakeholder engagements, where we work together to think about what are those risks that might shape future systems. How can we co-design pathways to represent what those future systems will look like? What are the specific adaptation and mitigation packages that could address those challenges? And then how do we co-evaluate the impact and iterate back through the cycle until we come up with pathways and packages that make sense for a given situation? The final thing I'll just highlight is the tools and technology. The next generation part of what we're doing is very important. And I'm just going to, again, take a snapshot out of one of the animations that Karen showed. We are increasingly able to access computational power that allows us to approach the information density that we know is happening in agricultural systems. We know that there's information coming off combines with an incredible amount of data collection. We would love to figure out how we can better work those data and the models to support all of the systems so that we can understand things on these big perspectives and on the smaller perspectives, bringing in data assimilation, machine learning, all of these new trends that we want to pull together. So with that, I'll say thank you, and on behalf of the AgMIP community, we really look forward to making connections in this room and following up from there. So I think with that, I'm going to turn over to Laura, who will tell you a little bit more about a specific application.
Wow, I am a little bit impressed. Not a little bit, I'm really impressed. I am so lucky to work with such great researchers. So I would like first to thank you, Pintia, for giving me the opportunity to share the Senegal experience of using AgMIP science for evidence-based policy and policy dialogue. Thank you. The work that I will be presenting is the work led by IPAR, and it's a small team, but quite active, you will see. Most of us, I think, in this room, we want now, or we have wanted at some point, to change the world for the better. For AgMIP scientists, this is their everyday job. Influencing climate policy, decision-making, and action is, I think, one effective path to changing the world for the better and having then a positive impact on the planet and on people. Techniques, tools, all the really brilliant maps, animations that have been presented by Karen and Alex are here to improve climate change, yes, adaptation, yes, but this is only the tip of the iceberg. If we want to work on climate change adaptation and mitigation, we have to dive deeper, and that's what we do. The NASA and AgMIP researchers take into account multiple dimensions like context-specific policies, institution, and governance. They also have very deep reflection on evidence production for the next generation programs. When we think, for example, on nutrition-sensitive program. We also do a lot of capacity building, knowledge sharing, and knowledge translation for a shift of thinking toward more systemic solutions. I will talk about Senegal and specifically about a small area in the heart of Senegal where the AgMIP adventure started for us. Models are showing that Senegal will experience rising temperature and decreasing rainfall. This is no news for most of us. But Senegal has also a non-negligible exposition to climate risk extremes and unfortunately a very low capacity of adaptation yet. How do we change that? We choose Nioro because this is an area that is quite representative of 70% of the agriculture in Senegal, with millet and peanuts that is grown in annual rotation, really simple fertility management but not very efficient. We see fallow duration that tends to disappear under population pressure. We have really small use of manure for cereal farming, and it is mostly limited to homestead, and also a very small use of synthetic fertilizer. Most of the time it is used on peanut because it's a cash crop. This is the context. We are talking a lot here about COVID. What happened to Senegal during COVID? Senegal government supported most of the sector, and agriculture was one of the sectors that was supported for aid, emergency aid. We spent $2 billion US. It's only your budget, but that's quite some money. I do have to validate that on this emergency aid. And since the onset of the pandemic, the Senegalese budget deficit has rose from 3.9 to 6.1%. So we are not in a good place right now. In the meantime, commitment for climate action, climate finance, the so-called green finance is still lacking, and we are waiting for that. In this context, you may say, so nobody is working on climate change in agriculture. Yes, a lot of people in Senegal are working on it. There's an increasing diversity of stakeholders that are including climate action in their mission, especially at the intersection with agriculture. This can go from ministries like the Environment Ministry, Agriculture Ministry, to research institutions, to civil society and farmers' organizations. Our work is based on the dialogue with these stakeholders to identify key policy drivers of change, indicators to construct the agricultural pathway to a better adaptation to climate change, but also parameters for regional and also national economic modeling. For the past 5 years, we have seen development planning that are mentioning climate change. But when we look deeper, we see that it's only mentions. All this work is not based on real data, evidence on climate change at a relevant scale for these stakeholders. So we need more planning for adaptation in the agricultural sector, and we also need the production of scale-relevant data for this community. In Senegal, with AgMIP, we have realized a regional integrated assessment based on the Nioro area. And we have done climate projection, crop simulation, economic modeling. We have also worked a lot as the IPAR team on the participatory prospective exercise with what we call the representative agricultural pathway. And we have identified key messages and action for agriculture in Senegal in the context of climate change and also in the context of the upcoming petrol and gas exploitation in our country. So I can give you some of these messages. One of them, for example, inclusive approaches in public policies are implemented alongside significant development of community initiatives and greater accountability of grassroots organization. It cannot be done on a top-down approach. We really need to go from the bottom to the top. Agroecological practices are mainstreamed. This is really a strong a wave that is happening now in Senegal, agroecology, and we need to see how to integrate that in the way we look at agriculture and climate change. So this work of scenario designing and prospective with the representative agricultural pathway help us, researchers, to understand the overall system behaviors, its response to shock, the enablers that drive the system to evolve and to realize national priorities, regional priorities, the goals that are set by the communities. But these tools also, or these methods also was very useful with stakeholders' engagement and the appropriation of this evidence for them. So this participative, very iterative way of looking at the future, building together these scenarios is also a good way to engage and also an excellent tool for future planning of climate change adaptation. This regional integrated assessment was realized not only in Senegal, but recently in 2 other countries, Zimbabwe and Ghana. And for all these 3 countries, we use the same AgMIP approach. But even though the approach was the same, the content was very different. We had very context-specific data, very context-specific and local models for each of the countries. So it's not a one-size-fits-all. It's not the solution that will change and make the solution for everyone. We need to look at each country and each situation differently. Currently, we are working on scaling up from regional to national integrated assessment. And this is a really strong demand from the stakeholders in our different countries. That leads me to the demand-driven support to stakeholders. As a think tank, we have limited resources, limited human resources, but yet we cannot look down when we have demand for stakeholders. So we have been really, we have tried very hard to support this demand because we have created a trust relationship with the decision makers and also with the stakeholders, the other stakeholders. We managed with the support, the back support of AgMIP to be part of the scientific advisor of the Senegal government on agriculture for the COP. We are part of the steering committee for the different vulnerability studies in the National Adaptation Plan process. And we also animate a community of practitioners on adaptation to climate change in Senegal with nearly 60 institutions. And each time, AgMIP evidence have been informing the process. We are now to the point where Senegalese decision makers are convinced that taking into account climate change in their work is essential. But this process is not an overnight process. It started in 2006, we are in 2022. It takes time, but it also takes money. A little blink to potential donors here. It is not project money. It is money to answer to the demand, and it's money to create pilot for the different initiatives that we have. So the momentum is now, with a lot of strength and opportunities for climate action in agriculture. However, we must prepare, because we also have a lot of challenges and weakness. The tools that have been developed by the NASA and the AgMIP consortium are integrating the stakeholders' demand and needs, and they are really tremendous use for ongoing adaptation planning in the agricultural sector, at least in Senegal. For example, we have this Impact Explorer platform that you should go and visit, that is very versatile, yet powerful. And this tool is really able to convey great science in a simple manner to decision makers. I will finish with this. Using this tool and all the other more conventional engagement participatory tool, we are trying, at least, to support and accelerate the agricultural adaptation to climate change in Senegalese policy. I will finish with one sentence, one citation from a philosopher. I know the sentence in French, so I will try to translate in English. It's it's not the path that is difficult. It's the difficult that is the path. So now if it's difficult for us in this very challenging context, that means that we are on the right path to success. Thank you.
Had our 3 wonderful talks from our panelists. I'm going to ask them a challenging question, and eager to hear their answers. Here's the question. Looking forward, what excites you the most? What pathway do you see forward for using science to advance healthy food and a sustainable planet? All right, Karen, you're up.
All right. It's a great question, and I've really enjoyed hearing all of the perspectives on stage today. I think, look, we know that we're seeing changes in our climate that are leading to real challenges in our communities around the world and in economic sectors around the world. What's most exciting to me, though, is the pace of innovation that we're seeing in technology, in use of information, and most importantly, in ways of partnering. I think together we're going to be able to address these challenges, and so for many years we've been partnering government agency to government agency. We know how to do that. What we're really working on now is partnerships with decision makers at state, local, tribal levels, with the private sector, with NGOs, with governments around the world. Those partnerships, I think, are going to be the key to harnessing the power of innovation to address the challenges in front of us.
Wonderful. Thank you, Karen. Alex, you're up.
Yeah, there's a lot of things to choose from here, but I think what I'm really excited about is what I've seen in some of our AgMIP projects when we engage with the local experts, the scientists. I sit in New York City. You know, I shouldn't be running the crop model for Senegal. We need to work with Laura and her team, and when we've done that, it's incredible to see not only, you know, the more accurate and better depictions and more useful set of information that comes out, but even getting to the level of model development from the regions that are truly vulnerable is really, really important to get us beyond the major staple crops to some of the critical food security and nutrition crops. And also just to see how the process snowballs once you have the models, once you have the model developers. The education systems, you know, can take off and have more and more people brought into that fold, and more connections with other disciplines and policy processes.
Great, thank you. Laura, what do you see as the most exciting way forward?
Whenever we talk about science, I get really excited. But science for a sustainable food system, I say that I would say the power of local. It's in part what Alex was saying, using local expertise, but it's also in terms of modeling how we can go from very large and global model to downsize them to the scale that is needed for communities.
Yes, wonderful. Thank you so much. Now, turning to the audience, I think we have some, it's hard for me to see, but do we have some microphones available for some Q&A? And I need our organizers to tell us how much time we have, but I hope we have at least time for 1 or 2 or 3 questions. Any comments? Yes, please. Please say who you are.
Partnerships is the right word. more about collaboration, and then I moved to hyper-collaboration, because that's where we have to go to together if we're going to solve these difficult situations that are in front of us and turn them into opportunities. So just not so much as a question, but a comment on something that I think you hit on. And maybe everybody in this audience wants to go home and think about that, because I know my problem here in Des Moines, Iowa is pretty much everybody's problem, wherever they're coming from. So anyway,
Thank you so much for that comment. Yes, and the need for hyper collaboration. How much, one more question or comment? Wonderful.
Yeah. Question.
Yes? Okay. One more. Yes, please. Please say who you are.
I'm Geeta Lakshmi. I'm from India, currently heading the Tamil Nadu Agricultural University. And it's a great pleasure to be here and listening to all of you. And, I'm not going to have any questions. I'm just going to share a little experience in a minute. This is truly a multidisciplinary project where we had an opportunity to take one part of the important thing, like a climate to crop model to economic model, integrating stakeholders, and then taking everything into a simplistic thing through the Impact Explorer. It's really a great experience, and through this we were able to engage a lot of policy makers, and we were able to do something like evidence-based policy. So it's a great experience working with all of you, and really, for example, in India, we have been working in 3 different areas, like one from south and from the central and from the north. It was a great experience looking at the different agroclimatic zones, how it is impacting, and putting everything together to develop a national policy. Thanks for the great experience.
Thank you, Geeta, and welcome. It's great. Well, please join me in thanking our wonderful panel. Do you want to make a comment?
And I just
Final
want
comment.
to once again give you my heartiest congratulations, and I really appreciate not only the work you've done and this community for recognizing it, but also for creating the opportunity for us to come and have this conversation and increase the partnerships, as you said, Alex. So thanks and congratulations.
Thank you, Karen. And thank you so much for coming and being here. Great.